good afternoon, everybody. Welcome to 3D Scanning with Tom. My name is Regina, and if you have any questions about how to log your Acts 48 hours, I can help you do that on the website, the PETE&C website. Just be aware if you have anything plugged in, that you'll be traced on anything, and please turn your devices down so we're not interrupting anything. Take it away, Tom.
Okay. I'll finish this thing. So, welcome. My name is Tom McLaughlin. I teach at New Hope Silbury High School. I've been teaching for 20 years, math and computer science. I like to play with all types of things tech, and I like things that are free even better. So what I'm going to show you today, it's not all entirely free, but it's fairly inexpensive. The technology that we're looking at is 3D scanning. And the first question that somebody might ask is, well, everybody upstairs, there's like 3 or 4 different locations. We're all doing 3D printing. Let's see, many people, actually I saw one person. One doing 3D scanning, but it was like a side piece of their thing.
In the big auditorium, there's one guy.
Yeah. So why are we doing, why are we talking about 3D scanning? What's the important part of that? Well, there's a couple of reasons. 3D scanning, of course, is great because it's artistic. So we're talking about STEAM, right? S-T-E, and the A is usually silent when we pronounce it, so we call it STEM. But we talk about 3D scanning as an art piece. Taking something that a student has made or something that they find in nature and they want to manipulate in some way and scanning it into a 3-dimensional environment. Second reason, surveying. Applications in mathematics are immense, but even applications in practical engineering in the modern world is even bigger. 3D scanning is used modern today to scan entire environments rather than having people stand and take individual measurements with a tripod and a laser pointer. They have very sophisticated scanners that essentially they point and they shoot and they have the entire landscape in a 3D model that they pull into AutoCAD and any other program that they want to manipulate. Augmented reality, I'm sure some of you saw the Google Glasses upstairs. That's all fantastic. If you have hours and hours and hours to spend modeling this stuff by hand, suppose you want to kind of cut that time process down a little bit and you want to show some models and some 3D virtual reality to the students. You go to a museum, you go to a science exhibit, you do some science experiments at home, and you just want to get that 3D model for the students to reference in the future. This will allow you to do that, at least this process. And then finally, I like to think of it as the Star Trek today. It's a modern replicator. Okay, maybe not quite, but it's pretty close. You can 3D scan something and then go up and buy one of those printers from upstairs, which I don't work with any of those, and then come down and print it out. That's a modern replicator. I mean, that's really cool that you can take something and make a physical copy of it and print it out somewhere else. So, a couple examples of that. Has anybody worn a Fitbit? You know those exercise things? Isn't it annoying to wear 2 bracelets? How people find that annoying? You got your watch, and then you got your Fitbit, and then maybe you have another bracelet, I know I found it a pain in the neck to wear 2. Well, someone got a brilliant idea. What if we took a Fitbit and built something to sit on your watch? And you can take that little Fitbit thing and fit it right in your watch. Oh, I only have to wear one thing now. I don't have to wear 2. That's fantastic. So one of the ways they could have gotten that model, that Fitbit, would be to 3D scan it. Designing in 3D, especially when you're going around real-life objects, either requires using a caliper and being very precise, having some type of original 3D STL file or 3D model from the company, which I don't think Fitbit was putting that out, or doing a 3D scan where you can take real measurements and get a real design based upon some type of physical object. They can 3D scan their phones, their cases, they can 3D scan other objects and come up with good designs to solve real problems. Maybe there's a gear, an old gear that needs to be replaced. Rather than going through and measuring all those teeth, they could go in and just get a 3D model. It may not be perfect, but it's going to give them enough that they can then build their 3D model on top of it. The other nice thing about Shapeways is you can sell stuff on Shapeways. So they could go ahead and create something and then just sell their models. Not even the physical printed object. They can sell their three-dimensional models. So we're talking about even connections into business, in the FBLA and other groups. I know one of the things we talk in our district is we can't sell food anymore. How many people are in that boat? Can't sell food. That's it. You're out. No more food. But you can do other more creative things with 3D printing and selling other types of objects. And that's where the kids get the tie-in, where they can say, yeah, I can make something. We can make a real product. We can turn around and we can sell it. Another example, how many people have been to, maybe not up here, but King of Prussia Mall? Okay. So in the King of Prussia Mall, they have this really kind of neat thing. It's a body scanner. I didn't go in it. My wife did. And I kind of pushed her into it. And they do it for free. You walk in, and they scan you. I see this is the Wi-Fi. It's kind of there. It is. That's what it looks like. You walk in, they scan you. You put your hands up. They run the scanner around you. Full body scan. And then when you walk out of it, they tell you what jeans fit. I see another guys are going, what? Yeah, my wife thought this was a huge deal. So she's like, yeah, and they gave her a list. That store over there has this pair of jeans, this style, this size. Go try it on. It's going to fit you. She's like, no way. Yeah. So she went in, got the scan, got the jeans, tried them on, and says, this is fantastic, but I'll never spend $200 on a pair of jeans. But the technology's there. They just need to kind of port it over to Walmart and Target. And that's what
She left your friends that she was wearing it on?
Yeah, they did the full 3D body scan. Yeah, you know what? Yeah, it's glass. You can see through it. That would not be good. Then I really wouldn't get into it.
I didn't know if it was like a changing room. You just stand in there by yourself.
Quirky's a really kind of cool website. Again, it's another type of design situation. Only this is reverse. You don't sell your own stuff. What you do is you come up with a model, and if enough people like it, they'll fund it into production. They'll say, you know what? Enough people think this is a good enough idea that we're going to take your product and we're going to put it into production and we're going to sell it. And we're going to pay you. We're going to give you the royalties. You have ownership in this product now. Now think about the opportunities for kids there are here. We want to hook kids in. We want to get them interested in math. We want to get them interested in science. We want to get them interested in design. And we tell them, hey, listen, if you work hard and you get a good enough model, somebody in here could possibly have the ability to sell their product. That's fantastic. You know, it's not, when we talk about real world, nothing gets more real world than bringing it down to consumerism. I mean, we all live in a capitalist society. We know how that works. They're online. They see all this stuff. They would love to sell their stuff. And this is an opportunity. There we go. So have all types of design options, all types of things. And some of it is literally just a 3D model. They don't even make a product. They never print it out. They just do a design. And then if enough people fund it and like it, there's a toothbrush with toothpaste attached to the top. Something easily a kid could have 3D designed. Maybe it was designed by a kid. I don't know. Take a look. So we talked about the why. I think there's a good idea, but how about the how? Well, 3D scanning has actually been around for a long time. It's not a new thing. But the technology to accomplish it has been fairly expensive. There's three main ways of doing it, but the process is pretty straightforward. You need to develop something called a point cloud, which is a series of points in space that mark the surface of your object. Now, if I was going to connect 2 points in space with a straight line, right, we could all picture that, right? 3 points in space, give me a plane, right? And you can see as I add more points, I can start to get my three-dimensional objects. 4 points in space, we can get a space. The more points I add, the more texture I can get. So the goal is to get as many points as you possibly can to get a good texture and a good 3D design. Then all those points are connected into surfaces. So it creates a 3D mesh. So with those points, do all the geometry and connect it, and you get a 3D mesh. More points, better mesh. Finally, you have to smooth it out. You take that mesh, all the rough edges, and you smooth it out. Last piece, other than being a gray blob, you want to paint it. And you want to paint it with some type of texture. Now that might be a texture that you have imported. It might be a texture of the original object. And that's the basic idea. Here's an example. This is Monmouth Castle in southeast Wales. And you can see this is a point cloud. That's what a mesh looks like from that point cloud. We take something and we smooth it out. And now it looks like a clay model. And then finally, that clay model adds a surface. So this is what, if we took a graphic of somebody's clothing and cut it out and laid it flat, that's what it would look like. Or if you imagine, if you take the globe and you open it out, sometimes it's easier for us to see, and you have that shape, that is the globe. That's a surface that you can attach to a 3D object. Now this all sounds really complicated. Right? This sounds like there's a lot of work involved to make this happen, but it's actually not as complicated because the modern software and technology that we have allows us to do it. The three main methods. Laser was the original. This was the way that it was originally described and designed. There's lots of do-it-yourself projects that you can find on how to use lasers to do this. You essentially take a laser and a camera, and you run the laser over the object with the camera, and the software picks up the points where the laser touches the object and distorts, and it will give you your point cloud. So all the real work is in the software. Not very expensive to set up, however, does take a bit of sophisticated know-how. You know, you have to get a laser somewhere, you have to set it up, you have to get the table to get it to rotate. You have to have the camera set up, right? But the software in most cases is free. Does require a little bit of know-how to get set up and running. I typically don't go too much into the laser software because there's so much do-it-yourself information out there, and it's kind of up here for most people. But if you're running an engineering class, designing the laser scanner with them is absolutely a great project. However, there's two other ways of doing it. The first one is called, and I always screw up the way you pronounce this, it's photogrammetry. I think I got that right. Photogrammetry. And I really like this method because it's very accessible. It essentially consists of taking a whole bunch of pictures. Take a bunch of pictures, you move around your object, get lots of good views of it, and then you crunch it into some software, and the software spits out your mesh, well, your point cloud, then your mesh, and attaches the images and gives you your 3D surface layer. Really nice. Takes a lot of computing power. It can take a long, long time for the computer to analyze all of those images and get that put together into your picture to get your 3D model. The last version is the Kinect. I'm going to demonstrate that here today. But this is the original Kinect. You can get them on eBay for like $15 at this point. They have the new one, the Microsoft One Kinect, which is a little bit better because it works natively with some Microsoft objects, Microsoft apps that are built in, and then connects right to a 3D printer. So you got to go up to about $50 if you want to get that. So for about $15 investment, this is a pretty good tool. And we'll demonstrate that.
What was the other one?
Well, the other one, the Microsoft One.
Okay.
Xbox One, yeah.
Okay.
So some pieces of hardware that you would need to do each of these. First, the laser. If you were going to do the laser method, you would need a laser line level, you need a computer with a webcam, and you need a foam board because you got to build a box. Put this in. Once you do that, the software that you would need is David Laser Scanner software. And all these resources are up on the link, so you can just click on the link and you'll have this PowerPoint, and these are all hyperlinks, so you can click right to it. And then you need Blender. How many people have ever worked in Blender? Okay. Oh, I hear the yeah. Okay, so when you open Blender, if you've ever opened up Blender, it looks like you could build the Eiffel Tower if you had about 3 years to figure out all of the controls. Now, I love gadgets and I love figuring that stuff out, but then I look at it and go, wow, I don't know if I could teach that in a marking period. You know, so the learning curve on Blender is fairly high. At a tech school, absolutely, they should be using Blender and they should be doing modeling and design, and that should be part of their curriculum throughout that tech program track. But maybe if you're trying to do this in your classroom as a couple-day lesson for a one-off or something like that, you're not going to want to hit this. This is just going to be way too much overkill for you to use. Essentially, you print out a sheet of dots. The laser gets scanned over, and where the dots get blocked out and where the laser crosses the object, the software does all the work for you. There's a link to exactly how to build it. It's by some guy called Tinkernut, and he has the designs and he has demonstrations and all the software for it. So if you really want to tackle this, that's where you go. This one's a little bit more fun. Photogrammetry. And we're going to try this. You can open up the app and I'll take you a look, let you take a look, but you do need some space to make this happen. And there's a couple pieces of software that you can use. The first one, and I had some of you download, it's called 123D Catch. It is free for the iPhone, for the iPad, and for Android. It is part of AutoCAD's suite of stuff. If you have not looked at AutoCAD stuff, they give away a ton of software. ThinkCAD is probably the easiest 3D modeling software that I've seen for kids. ThinkCAD, 1, 2, 3. ThinkCAD, 1, 2, 3. Oh, Tinkercad. Tinkercad. Yeah.
So is 1, 2, 3 catch with a K or catch
C.
with a C?
1, 2, 3 D catch with a C. But before we dive into that one, I wanted to show you some of the other ways of doing it. The best software that I've found so far is Memento. And it's free, and it's relatively new. I've updated this since the last time I've given the talk. Some of the other software is more difficult to configure and get up and working, but Memento is pretty nice, and I'm going to jump over to that. Here it is. So you can see this is a rock. Just a rock, I know. Not very impressive. But it's a 3D rock. And you see all these little triangles? This represents all of the camera shots that were taken for that. So the computer has to take all of those images. Now I think they limit you in the free version to 70 images. But you take a whole bunch of pictures. All the way around the rock. Like a lot of pictures. Like a whole lot of pictures. Now, unfortunately, like I said, the free version limits you to like 70 pictures. So this is done with just 70 pictures. But I took a whole bunch of pictures and I let the software pick the pictures it wanted. And it went through and just picked pictures that it wanted to use. I figured it probably knows better than I did. So it just grabbed some pictures, and then I pressed the button, and I'm not going to do it now because it takes a long time. But I was able to turn off my computer and drive home. Because what it does is, it uses a cloud server. It'll take the photos, and once it uploads the photos to the cloud server, it will do all of that on their end. So in terms of 3D scanning, the biggest hurdle, the biggest thing to get past is the processing power of the computer and the time needed. I used another piece of software to do this. It's called Visual SFM. Unless you're really into tech and computers, I wouldn't even go there. It took probably 3 days on my laptop trying to get that rock image to compile and go through all the processes necessary to get to a 3D scan. So you need a My laptop's doing all the work. So the beauty of using this new software, and this literally just came out in 2015, so this was a huge find for this. It does everything for me, and by the time I drove home in about a half hour, I was able to go back to the software and open it up, and it downloaded the image, the 3D model for me. And this is all free, I didn't pay for any of this. It allows me to take the image and export it. I can export it to a 3D model. I can export it as an image. I can export it as a video. I can also model it and edit it. I can measure it. We're talking about the math applications. Go ahead and come up with all of the measurements on that object. Now find its volume. There's your calculus applications, right? Slice it, find its volume. Find the area of one surface. Pick a surface, any surface on that rock. Find the area. So we can go take this all the way down to middle school. And the fact that it's something real and physical, that makes a difference. You know, it's not the rectangle I drew on the board. It's the rock in front of the school. That's not my rock in front of the school. Yeah?
What's the file type for the exporting as a 3D?
STL. It does, actually, I think it does multiple. I think it actually gives you a choice. So you can do OBJ, and I believe it also let me do STL. I thought it did. Maybe it didn't. But once you get it in an OBJ, you can pretty much do anything from there and convert it. OBJ is pretty universal. STL is fairly universal. You can upload it to Tinkercad or ThinkCAD. I always get the names wrong. Tinkercad. You can upload it to that as an OBJ. There's lots of pieces of other places you can go once you have that. Lots of 3D scanners will let you start with an OBJ, and you can go and convert it to your G code and all that fun stuff. You can also edit it in different ways. You can extrude it. You can change the texture. You can change the software. You can change it. And I think that's pretty cool. One of the coolest demonstrations I actually use in computer science is someone took a rock range, and they took that rock range and they morphed that image so it represented the Dow Jones. So it took a real life image and then modified it so it represented something else. Think about that effect. You know, this is a rock, range of rock mountains. And when you modify it though in a certain way, you can make it look like the Dow Jones. So think about the different ways that kids could modify this and mess with this to get different concepts and ideas across. Not just, oh, this is a rock. It can be a whole lot more of that. And this is very easy to do. It's just taking pictures. Anybody can take pictures. Any kid with a phone can take pictures, an iPad, an iTouch, any device whatsoever, and they upload them to this, and they can let it run the software. Any computer that has a hard drive can do this. I gotta be careful with that. If you don't have a hard drive, you're not gonna have anything to upload pictures to. So you need to have a hard drive, you need to have somewhere to load the software and run. This is not going to run on a Chromebook, but it'll work on any laptop or computer. I don't know if it works on the Mac. It'd be worth checking. I didn't check that out because I don't own a Mac. But the next app I'll show you definitely works on the Mac.
When you took the pictures, so you just took them with your regular camera app?
Regular camera. Or the better resolution image that you get, the better 3D scan that you get. So this is what it looks like as a 3D image. And hopefully this will load fast. They're lying, it wasn't made with 1, 2, 3 yet. I just have, because this has got a nice modeling software in there, and I can always keep this handy. So as it's pulling up.
What was the website for
There, so on the presentation program side, if you go to the program for the PETE&C, next to my name on the far right, there's a little link. When you click on that, it gives you a zip file that's on Dropbox. And if it doesn't, I'll double check it to make sure it's there, but it was there earlier. Okay, I'll double check it before we're done. But there we go, here's our 3D model. And I can manipulate and move it around And you can see the underside of it, which is the same as the top, because it just kind of ports the image. But what's interesting, this is an interesting experiment to do with them too. The human eye can't tell the difference between the bottom and the top. You ready? If you position this the right way.
So if you 3D printed this, though, it'd be hollow.
It could be hollow, but once I 3D print it, once I put it into software, I could make it solid.
Yeah.
I could choose a fill for it and end up fixing that. Because it doesn't recognize that it's solid, that it's hollow in here. When I put it into the 3D software, I can fix it. So that's Memento, and I'll put that right back up. So it's memento.autodesk.com. Who would have thought? Our friends at Autodesk. Fantastic stuff that they have there. Here's another one. I didn't download this one because once I found Memento, I kind of fell in love. So I got a little glassy-eyed for it. This is also free. If I can get my link to work. There we go. This is good for larger landscapes, whereas the AutoCAD software is great for smaller stuff. This again it's not free, but it has a 30-day trial. And if you have enough email addresses, you could probably get that to last for a while. Come on, we all know that. But even if you could only do the 30-day trial, you could only do it one time with 30-day trial. Imagine if you took a tour and you went to France. I said, this is an opportunity for me as an educator. I'm going to take a whole bunch of pictures. And I'm going to take those pictures and I'm going to make a 3D model so I now have that for my students forever. That's fantastic. So even if you only do it yourself. One of the things I did in my youth was I went to the Capitol building and I made this great video of me demonstrating the elliptical nature of the ceiling. And I videotaped it. In fact, at one point I had an entire crowd of people around me, cheering me on, looking at the demonstration. They thought it was fantastic. I videotaped it. Somehow, over the span of my couple years of teaching, I lost the videotape. But I always said in the back of my mind, I can always go back. I can always go back to DC and do that again, right? I can't. It's closed. I can't go back and ever remake that. So as educators, sometimes we take for some of these opportunities for granted. You may only be given one chance to do something like this. You want to immortalize it as best you possibly can. So here's a great way to do that, making a 3D model of something. Had I had a 3D model of that to show my students, well, granted, it was years ago, but had I had a 3D model of it, I'm sure I could probably find one now, I could do all the math with them and figure out where the foci of the ellipse are that's making that happen. Where exactly in the room is that happening?
Do you hear students using Memento to create 3D models? Like go to homework assignment, take 70 photographs of an object?
I have not yet. I'll be honest with you, I have not yet. Because like I said, I just found this software. I've done it with some of my kids as this is kind of cool, we played around with this. I want to do it in my new course that we're working on that started this semester, my Maker Math course, as we move towards 3D scanning and 3D modeling, but I haven't done that yet. Again, part of the reason, because the processing time just takes so much, but this takes that out. And that's really, really cool. It makes it definitely possible. The last one is the 1-2 3D catch. Oh, sorry. For the SFM, you still have to go through MeshLab and Blender and all that to clean it up. But you can always use MeshLab and Blender to clean up any of your 3D scans. You can always go back and edit it. If you really want to do something and you're good at that, absolutely. You can go back in and take any one of these and pull it into some of those more sophisticated tools and modify that image to make it even better. So the 1-2-3D catch. This is the one that you probably want to definitely use with your kids. This is the one that's free. They can all get on their portable devices, and you can send them home with a homework assignment to actually do. And essentially, the way it works is you take your camera, and you look at an object, and you walk around the room with that object in the center, and you take pictures of it. Now you have to have a good distance between you and the object. You also have to be able to get above it. So maybe putting it on the floor is a good plan. I've also seen people do turntables, but sometimes the software doesn't pick up the turntable, the fact that you're moving, because it's based on an accelerometer. You actually have to move around it, so that's a little bit trickier. But you get a collection of pictures, and it tells you when you've got enough pictures. It has little blue blocks that let you know that you're taking the pictures in the correct spot. Once it does that, again, it uploads all the images to AutoCAD, and then it just says, we'll send you an email later. We'll let you know when it's done.
It's like gunslip.
So when they do that and they send their email later they get their message that the 3D image is done. And I'll show you a couple of the ones I've done with AutoCAD 3D. All right, so I did this really, really quick, so don't judge. Has a couple holes in it. Lighting makes a difference here, so it's definitely something you want to play with. It's not something that you want to do just on the fly. The other software is better for that, and one that you only get 30 days to use. Again, this takes a minute. Our Wi-Fi's a little slow. But as this pulls up, think about the things that you can do with your kids. Just start thinking about that. And as you're thinking about that, throw it away. Because I want you to have your kids think about it. Because they're going to come up with stuff that is well beyond anything you thought of. Show them the software, demonstrate it for them. Give them a challenge. Say, I want you to go home, 3D scan something, and I want you to give me as many of the dimensions and models of it as you possibly can. There we go. There's my Phillies hat just sitting on the blanket. And that was done with my phone. So not bad. But granted, I did it fast. Has a couple holes in it. Not as many pictures. It's a stool in my classroom. Notice the floor shows up between the legs. So it does get a little confused if you have an object with holes in it. You know, it's going to be difficult for you to figure out what goes where. So solid objects definitely work better. Yeah?
Are you able to upload these like Mathematica?
I haven't tried it, but does Mathematica take STLs or
I have no idea.
possibly and do calculations on it?
Two calculations.
Yeah. Well, one of the nice things about the other software by AutoCAD, the Tinkercad. Is it Tinkercad? Mm-hmm. No, I don't know if that's the one. No, see, I don't think it's the Tinkercad one.
That's the really easy one. There's also 1, 2, 3 design.
That,
There's 1, 2, 3 scope.
yeah, I know they have so many. All right, so this might be it. But I forget exactly which one it is. I'll post it in the thing when I find out the one I use. It does measurements. So you can actually take the measurements in that software on any 3D model and do it that way. And then what's really cool about it is I tell my kids it has a grid system on the bottom. So if I want to figure out areas and volumes of slices, I just push it through the grid and flip my view over so I can see it coming through the grid. And you could take areas and volumes to a different point. It doesn't have to be calculus. You can have your elementary school students say, okay, how many blocks are being covered by your 3D image? Great. Push it through another millimeter. How many blocks are being covered by your 3D image now? And you can have them go through and calculate, approximate the volume of this 3D object, this real thing, by doing slices. That's a calculus concept that you could probably do in 8th grade without too much difficulty. Then you could take that 3D model, there's software. If you look at my other session, there's software in there called STL Stats. That'll give you the volume and mass of that 3D object so they can compare their answers and see if their object actually meets their math met the actual specifications of that object. I think that's pretty cool. So there's lots of different applications that you can do once you have a 3D model to work with. So, and there's our chair. Again, you can see I got the floor mixed in there. Oops. So essentially the technique is you take 60 to 70 pictures. That's a lot of pictures. It does take some time. And you want to make sure that you get a whole bunch of views from different angles. And the software walks you through this, whether you're using 123D Catch. If you're using Memento, you have to take the pictures yourself. But you want to take pictures from the top, walking around a circle. And then you want to take pictures from the bottom, walking around a circle. The whole object. 70 pictures, at least those two angles. The more angles you get, the better it is. You want to get some close-ups if you want to get some good detail. And the software will take all of those pictures and put them together to make your 3D model. If you buy the full versions of these, you can have more than 70 pictures. That's the advantage of having the full version. That's the major advantage. The other advantage a lot of times is, and I'll show you in the Connect, is sometimes these limit the export, where it might put a watermark or something like that. Memento doesn't, and neither does 123D Catch. That's great. AutoCAD gives everything of their stuff away. I don't quite know why, but I'm not gonna, I'm not gonna question it. Yeah.
Could you put a white sheet underneath your stool? Would that help? Because really white colors don't seem too well. This might be difficult.
Probably, or even like a green screen. You could do something like that, and that way you could always go back and add in a different layer.
It doesn't help because it doesn't know your distance, right?
Right, but she's saying put the green screen underneath the object you're trying to scan, and then you can kind of take out the floor. Possibly. Possibly. It's worth a try. The shiny actually scans worse. If it's shiny, because you're going to get the light reflections off of it, it's not going to scan as well. It's definitely more difficult if it's shiny.
Right, well, scan session is not.
Oh, that's true.
Shiny.
That's true.
So if you have white shiny,
Sure. Hey, it's free. Go home, go back to your hotel room and grab a whiteboard from somebody upstairs. I'm sure you can get one, right? Start scanning and post them. Find me on Twitter and post them up on Twitter. That'd be awesome. So once you have your pictures, you import the images into whatever software you're using, and then you render them, and then that's it. By the way, I have to give credit where credit's due. The guy who took all the pictures of the rock, Phil Nolan. I didn't take the pictures of the rock. I happened to use them because I know it was a good set of photos. So he goes through and he has a whole bunch of things that he's done in terms of 3D software. And this is all done with this photography method. And this is all 3D modeling. So great guy for 3D stuff if you want to take a look at some of his artwork. Again, go back to that STEM with the silent A part. Going back to the art piece that we often forget in STEM. Okay, so we talked about all that. Oops. Too far. Does that work? My computer's being slow. Asking to get you into stuff. Okay. It just wants to die. Yeah, we'll just close that, see if I can get it to shut down. There we go. PowerPoint's awesome up to the point it decides to stop working. Okay, so you guys can see that. All right, I can leave it something. That's all right. So the Connect. This is kind of cool. You can get a Microsoft Connect for like $15 on eBay. And you can get the new version of Microsoft Connect for a little bit more. I've actually seen them as low as $50. You can buy them brand new for $150. The nice thing about the new version is it connects right into 3D Build. That is a native app for Microsoft. So if you use that with a Microsoft, it theoretically, should work better. But I just use this version. And essentially, this is probably one of the best things that Microsoft invented that didn't know it invented it. This has a camera, but it also has a sensor that tells how far away something is. And this is great for games, but it's also great for 3D scanning. So some very inventive people decided, let's take advantage of this device, and let's turn this into a portable 3D scanner. There's two main pieces of software out there to do this. The first one is called Scanner PETE&C, and you can purchase it for $129 last I looked. But they have a free version, and the limitation on the free version is you can't print right from their software. You have to upload it to somewhere else. The other one is Reconstruct Me. It's a little bit more, and again, it has similar types of limitations in terms of export. But if you just want to kind of go through the demonstration and show how this technology works, this is definitely something you can do with your kids. More than likely, they have one of these. So you could probably get them to bring it in, and then this is free again. So that's fantastic. And then, of course, 3D building. So let me switch this. Not the old one. It only works with the new one. Bye-bye, Microsoft. Okay. So here is Scanner PETE&C. Now, the major problem with this is you lose the texture. There's no texture with it. I believe Reconstruct Me, I think in the full version does something with the texture, but not in the free version. And if you look, I'm sure there's other pieces of software out there that'll work for the Microsoft Kinect. But what I like to do is take a look at it when it's actually working. So, repair, new. Okay, so, you can see there's 3 screens. The screen on the upper left-hand corner, anything that's in green is going to scan well. So we want to kind of get a good shot, and clearly you can see it works better if it's far away. So I can almost get this entire table here. You can see in the middle that you have the actual image, and you can see it is in 3D. So it's taking a live 3D view of this. So if you look, it kind of composites everything on the bottom, and everything that's in gray is not going to scan. Everything that's in green to different colors will scan with different quality. But you can move around as you're scanning. So the fun thing I like to do, and I need a volunteer, is I like to scan somebody's face. Because how cool is that? Come on up, we'll scan your face. I always get a volunteer. Some brave soul. Okay, so how do you feel about acid?
Acid?
No, I'm kidding. You get a volunteer. You never know what you get a volunteer. So you have to step back a little bit further away from me. Okay. So you see, you can see his face already, right? Okay, so let's see if we can get this. I got a 3-second delay to kind of get it back to the right spot. And I'm not going to do his whole head. Well, the nice thing about this, I don't have to walk all the way around him. I can just do the front. His ears, and the light might mess it up a little bit. Let's get his hair. It doesn't work well on my head because the light reflects. Don't plan. I'm supposed to make my jokes for scanning you. Does it hurt? It's pretty cool. It usually hurts later. It's when I post it on the internet. All right, so there we go. So I did my 3D scan. Thank you very much. So now this is being processed on my computer. That was pretty fast. Do you notice the difference? Did you hear what I said? That was processed on my computer, and that was really fast. I'm done. So I now have a 3D scan of his face. The other thing you can see is this is the final position of the connect, but you can see all the locations I had the connect in. So I can now see, if my scan didn't come out well, I can see the things that I could have done to make it better. The other nice advantage of this is connect doesn't get based upon the accelerometer, which means it doesn't care who's moving. Either you can be moving or the connect can be moving. So if you have this mounted and you take one of your students and put them on a swivel chair and they turn around really slowly, you can get a very nice 3D scan of them. And now if you have a 3D printer, you take this 3D scan and you export it and you print it out, and now they have their own action figure. How cool is that, right? Granted, that's really just gimmick. You know, at that point, that's just gimmicky. But suppose we're doing a math class, and I said, hey, let's experiment with the golden ratio. Let's take some measurements. Let's see how close you are to the golden ratio. Right? How fun is that, right? Maybe not with your students, but maybe with yourself, right? I'm more than happy to offer my face up for stuff like this, right? And say, all right, well, if I'm not exactly there, what would my face look like if we fixed it? Right? Made me as beautiful as I'm supposed to be, you know, put the eyes back where they're supposed to be and fixed it. So this is the great thing about 3D images. You can end up manipulating these things and maneuvering them around and doing whatever you want. You're getting their face into the computer. That alone, I'm looking at some of your faces now, and you're blown away by that. Think about your kids. $30, free software, and you're all engaged in it. That's pretty impressive. Yeah?
Is this the free version of Scanner?
This is the free version of Scanner. So, you know, a little bit of money, and you can get the full version, which allows you to export to the STL file and all that. But this, again, connects online to a different store system, and will let me upload the design online, which I can then decide to 3D print and do all that type of stuff from that end.
Can you keep it private when you do that? I'm just thinking if we scan
Yeah.
student faces,
It's your own account.
they go public.
Yep. It allows further processing, and it shows you some of the time that would require. So, you know, we had time to go through and kind of really sharpen this image up and make him look better. I mean, improving? No, he's fine. He's fine. Once that's done, you finish your processing, and you can go through and fill any holes in his head. It's so good to make these puns. Remove parts, colorize it. Good, right? There we go. A couple other options. So there's a couple other options you can do with color, and you're missing the texture piece, but then you can kind of put this on another piece and put that texture piece in. It's one of the things I'm not crazy about the Connect, is especially this one, you kind of lose some of the texture, but that's okay. You know, for a lot of cases, that's just fine, especially for $30, and it's live and it's fast. And if you're just using something for measurement, this is ideal, because it's very fast and very effective in getting those measurements and those details. And it's fairly detailed. I mean, you would all agree this definitely looks like her. I mean, him. Come on, you had to know that was going to.
Can I scan the torso of like an E-Man action?
You can, you can scan full body. You can do full body scans. It's not limited to.
He wants two
Oh, my
bodies.
head on
Oh yeah. Cut it apart and rebuild it. Make yourself bigger, stronger, faster. Worth $3 million. Yeah.
For measurements, if you're gonna have someone measure their face, would you use some kind of this program to like measure a certain known quantity and then?
I would probably use it in a different software. I would take it out of this, maybe put it into the ThinkCAD, and we could try AutoCAD, because there's not a whole lot in terms of great measurement tools built into this. But once you have a 3D model, you can port it into so many different pieces of software to get that data. Once you get this as an STL file, you can figure out surface areas, you can figure out volumes, you can do measurements between different facial points. So yeah, there's a whole lot of stuff you can do this. If you're doing animation with kids, just figuring out how the face works. You know, how many muscles do we have in the face? Get them to smile. Get them not to smile. Get them to do a half smile. And they can really kind of see all those pieces and all those things moving. So it's really interesting at all the different ways of incorporating STEM with the silent A into your work. So at the end, on my PowerPoint, there's also all the resources where I pulled some of the images from. And I'll double check the link in the, oh, you did find it. Okay, cool. So it is there. So there's a zip file, and in the zip file, you get, not the rocks. You don't get the rocks. You can have the rocks if you want to. I told you the guy you can get the rocks from. You'll have my, oops, wrong spot. Oops, that's not good. So you got the PowerPoint, and I think also, I thought I put something else in there. One of my other sessions I did earlier today talked about MakerMath and some of the applications of 3D modeling in terms of a 3D printer and what you can do with that. So you can also find those resources online. There's a couple of good links in there that you might want to look at, specifically the one about the statistics for STL files. That allows you to calculate mass and volume of any 3D object, which is, as long as you know the density of the material you're printing it out of, that's pretty cool. I did a lot of experiments with my kids. We were able to figure out how a boat would float in the water that they 3D designed. And then we 3D printed out later and tested to see how it floats in the water. So that's just another application for you. And my computer, again, is assigned to work on something. I'd be happy to entertain any questions that we have with a couple minutes that we have left. So feel free to pull out the resources. And I was really happy to have you. Any questions? Yes.
I have an iSense scanner. Have you seen those?
An iSense scanner.
Yeah, it hooks onto, you can get it to hook onto your phone or an iPad. It comes in 2 different sizes. Do you know how does that differ from?
It's probably very similar.
Because it uses Connect. It'll also use new software called, it's by a Citadel called Structure.
Yeah, I think, yes, I've seen that one too. I think what somebody did is they found out that the Microsoft Kinect does this for free. And they said, hey, what if we made one and then sold people this and said this is for 3D scanning?
And it's not that expensive. It's like $300.
Yeah, yeah. But I think it's almost exactly the same thing. The Microsoft one, if you happen to have one of those, I might try one of those out first because you could probably get those from one of your kids. They have the Xboxes at home. They could probably bring it in, and you could try it out with the software for free. Your kids have this stuff. They play these video games all the time. They have all this stuff.
It's the old one too. They probably have an extra one lying around.
Absolutely.
Was the 3D builder better than Connect?
The reason I like the 3D builder is because it's free, and you can export the STL files right away. So you kind of put the cost in the equipment, unless one of your kids have it.
But comparatively to Connect, is it better?
I haven't tried it because I don't have one of these. All I have is this one. I didn't buy them. I tried to find one on eBay before here, but you know,
3D
I'm
builder
cheap.
is only Windows 8 and 10, though.
Yes, the 3D one, whatever they call it, Connect 2. I think sometimes you can find it on eBay as Connect 2.
You plug that into the computer and it recognizes it without a driver?
Yeah, well, the driver's built into Connect. It's built into the software. And
Okay.
Microsoft 3D Build, because it's a Microsoft product, it's built into there and it knows to recognize it.
And you need cables connected to it.
You do. And most times the kids will have these, but you need the power cable to plug into this, so you can run the power right to the Microsoft Kinect. But if you buy this, most times if you look for this on eBay, you'll find it for $15 and it comes with it. And it's all there.
So the Kinect doesn't plug in without an additional adapter?
It just needs power. So it's plugging right into, this is actually part of the Kinect. This power source is actually comes with the Kinect.
It's got a set. Okay.
There's two different versions of the old one. You could buy one that had the power source and one that didn't.
If you bought the Kinect separate, it came with it.
Yes.
If you bought it with the newer versions of the Xbox 360,
It did not, correct. So you have to make sure you get the one with the power source, and they run about the same. I know, right? But Microsoft never realized, that anybody would be doing this.
That's basically just like a PoE inductor, right?
Yes.
Power over with the pack.
Well, and actually
but
they-
it's over. It's USB.
It's over. This goes right through USB, and it goes right into their software. And it's just running two cameras. One is getting your infrared distance, and the other one is just a video camera.
Unfortunately, that one's a little harder to find. We used to, it's like $40 for